So this question is to find the Fourier transform of the double exponential e to the power minus a absolute value of t with a positive value of a. So if we were to sketch this, it would look something like this. So it's a double-sided exponential. So the absolute value of t means that even when t is negative, we have e to the power minus a positive value. So definition of Fourier transform is simply the integral from minus infinity to infinity of our signal times e to the minus I omega t. And what we do is, because we're given our signal, we simply replace x of t with e to the minus a absolute value of t. Now, because we have this positive side and the negative side, we can split the integrals into two. So we can say this is an integral from minus infinity to 0, that's for the negative time, plus an integral from 0 to infinity. So we have two integrals, an integral for t less than 0 and an integral for t greater than 0. So for negative values of t, we can replace t with minus t. So it's as if we're integrating e to the power minus a times minus t times e to the minus I omega t. And for positive t, it's simply minus a t times e to the minus I omega t. So this is for negative time, and this is for positive time. Now, if we take the t as a common factor, and if we add the powers together, it will allow us to say e to the power t into a minus I omega dt. And the second integral, if we take minus t as a common factor, it will be a plus I omega dt. Now the next step is simply to integrate. So when you integrate, you simply divide by the derivative of the power there. So for the first integral, you divide by 1 I omega, and that's e to the t a minus I omega, no change. And that's from minus infinity to 0. If we just move that slightly to the left, I can then add the same again, but this time we divide by minus a plus I omega, e to the minus t a plus I omega. And again, if we move this slightly to the left, that will allow me to put my integral limits from 0 to infinity. So the next step is easy. You just have to substitute. So 1 over a minus I omega into 1 minus 0, and this minus sign will replace the plus, so we'll have minus 1 over a plus I omega into 0 minus 1. Now these two minuses turn into a plus, and we have the sum of two fractions. Now we could leave it like that, but we don't like to have the complex variable I in the denominator, so we can simply find a common denominator, which is the product, A minus omega times A plus I omega, and that simplifies nicely because that cancels with that. And if you remember, obviously I squared is minus 1. That will give us our final answer. X of omega is 2a divided by a squared plus omega squared. That's our final answer.